Well, thank you for being here, and thank you, Angelica, for inviting me to participate in this conference. I really enjoy being here visiting, and I am not sure I understood everything you said in the introduction to my talk, but my best card is that I can always say that without the plants, there would be no dinosaurs, and we can probably all agree on that. But the serious thing is that a lot of people forget about the plants, and just because they're so fascinated by the size and the sort of viciousness of the dinosaurs, that becomes the most important. I have worked with plants both in Canada and in Denmark, where I come from. You can probably hear I have a funny accent. And I have been lucky enough to work in Greenland, as Angelica mentioned, but 2 times Philip and I managed to work together in Antarctica. The first time we were in the Transantarctic Mountains digging out a dinosaur, and later on we were over on the peninsula on an island called James Ross Island, and this is this trip that I want to talk to you about, not the dinosaurs we found, but the plant fossil we happened to find. And it might not be obvious to you that Antarctica was very instrumental in providing terrestrial information because in one of the earlier expeditions, plant material was found on Antarctica, and that kind of showed that Antarctica had not always been like we know Antarctica today, but been actually connected to other land masses. And I think that is very interesting. The first plant fossils was actually found by whalers who came to fish in the 18th century. And one of the stories is that it was a Norwegian captain who was in 1892, he was around the Seymour Island, which is also over by the peninsula towards South America. And of course he was there to get seals, but he found a lot of fossils every time he came on land. And he collected them because he thought they were interesting. And at the same time, there was another expedition called the Dundee Antarctic Expedition, and by just pure chance, they ended up meeting up in 1892. And at that point, Larsen from Norway had been at sea for several months, and he was running out of supplies such as tobacco. And when he met the Dundee expedition, the Scots had still tobacco left, so they made a deal that he gave them fossils and he got tobacco. And that is why today some of these fossils actually ended up in Scotland instead of going to Scandinavia, Norway, and Sweden. But they did get described both from Scotland and from Scandinavia. So the Antarctic Peninsula and the Seymour Island is some of those places that I will talk about, and I just want to show you one of those places that an earlier expedition went to, and that was on the a Swedish expedition by Nordenskjöld, and again it was the same captain that had been on the expedition earlier, Captain Larsen. So interesting enough, they ended up on this island and they built this shelter to be able to survive through one of these awful winters in Antarctica. Otto Nordenskjöld was the one who was leading the Swedish South Pole expedition, and he left part of the crew on the island called Snow Hill Island, where this shelter was built. And during his expedition, he recovered material from both Jurassic and Cretaceous rock, and Cenozoic rock as well. And this was all plant fossils that they found. The expedition was helped by the Argentinian, and there is a book written in Spanish, you might be interested, about this expedition. And it is called Dos Años Entre los Hielos, and it's from 1901 to 1903, so it gives a really good explanation of what happened. And the reason why this book has been published is that when Nordenskjold got to Buenos Aires, he needed supplies, so he stopped there. And he was lucky enough to get in and have a conversation with the president. And the president said to him, "Can you please take this young man, Sobral, on your expedition?" He was a lieutenant or something like that from the army. And then the president offered him the supplies he needed. So that is why there today is actually a very, very good record of that expedition. And I would say it is as exciting a piece of literature as any of the more famous expeditions known from Antarctica. So my experience together with Philip was joining the Argentinian Antarctic survey. They every year sent people to Seymour Island, and of course there is an Argentinian base, so this is what you see in the island here in the corner, and it's called Marambio. And that is where we landed first. We got our equipment there, and then we were taken out with a helicopter to James Ross Island, which is the big island you see with the ice in the middle. And our camp is where the line goes to. And the little area we were exploring is called Santa Marta's Cove. And Santa Marta Cove is a flat area, or relatively flat area. This is looking towards Vega Island, and what you see, the small orange dots there, is our camp. We were only 3 people together, and it was Rodolfo Correa that some of you might know. He is a paleontologist as well, studying dinosaurs, and we have worked with him for many years in Argentina, but this was an opportunity for us to go to Antarctica, which was very exciting. So Rodolfo had been there several years before and found parts of different dinosaurs. So of course we were there to find more of these dinosaurs. And the dinosaurs that had already been described are Andactopelta and Trinisaurus, and I forget the other one, Litostronia. Maybe I didn't pronounce that right. Anyway, that's the 3 dinosaurs that were known from this Snow Hill formation and Snow Hill Island formation. The island, or the area on this island where we were prospecting in, is very rich in marine fossils, so every day we went out and we could practically not step anywhere without stepping on marine fossils. But I would say it was very difficult to find anything other than marine fossils, except maybe for fossil wood. There's a piece there beside my GPS. We did succeed in finding small fragments of dinosaur material, especially we spent a lot of time in the area where Andactopelta had been found, and I think there was some of the fossils that were well preserved and worth maybe working on for some of the dinosaur paleontologists. So here is a close-up of the area in Santa Marta's Cove, and I knew from the literature that there had been found plant material near by, and there is that Lachman Crag there, and there are several paleobotanical sites there. And from previous expeditions, there has been reports of wood and wood from angiosperms and from gymnosperms, and there's also been leaves, and samples for palynology has been made, so they have also the spores and pollen from the plants that grew at the same time. So certainly an area rich in fossils. The day that we were going out and actually finding the little plant fossils that I will speak to you about, I took my GPS in Reach with me. I don't know if you are familiar with it, but it actually makes a nice track of where you're going. And because I had never tried it before, I thought kind of it was neat to try and find it. And it wasn't me finding the plant fossil, it was actually Rodolfo, and the area that he found it in looked like anywhere else in this area, and wasn't in any way different from where we had been the other days. And the little fossil looks like this, and I don't have a pointer, but what you see on A is the outside surface of something that is sort of half moon shaped, and B is the inside of the same fossil, and C and D is, C is the top view and D is the bottom view. And what you have to imagine is that this fossil once was like more like round, and unfortunately erosion broke it in two, so what we are seeing is only half of what it would have been if it had been complete. And it may not look very interesting, but what it is that it is the rhizome, or what is very close to the ground, where certain plants, instead of roots, they have rhizomes that produces both smaller roots going into the ground, but also produces the base of the leaves that then grows up. And this belonged to a fern that we do know today, and the fern looks like the picture here. It's called the royal fern in English, and I'm sure in Spanish you probably have a good name for it too. The Latin name is Osmunda regalis, and it is a very interesting fern because people always called it the flowering fern because it has the reproductive part growing on separate leaves instead of the green ones. It has them going up, so you can probably see in the picture there that the brown ones is where the spores are coming out. One of our students made me a reconstruction of what we had found, and what you are supposed to zoom in on is just the bottom part, and maybe it is not entirely correct because it doesn't necessarily have to be done in this way. It could also be slightly sort of like lying down in a horizontal way, and then the leaves would still grow up. But it's a matter of, you know, interpretation, how you see that. So this kind of fossil is not unknown to people who study paleobotany. These sort of permineralized rhizomes are quite common in the paleobotanical world. And I will tell you that today there's only a few genera and species of this kind of fern, but in the fossil record there is a lot, and it goes way back in time to the Permian, and that is what makes it a very interesting plant to study. So this is an image of how it looked from the top, and you can see small round areas, which is where the stem of the leaves would have grown out. And these are so well preserved that you can actually see the different cells, and I will show you that in a few minutes. This is SEM pictures of these tracheids that transported the water and the nutrients to the plant. And if we look at this one, you can probably see that there are very nice lines, and these are all in connection with that leaves have been growing out from the center of the rhizome. The cross-section of another specimen that already was described when we found this one is here. It's called Millerocaulis australis, and it is from a different island in the Antarctic area. It's from Livingston Island, but you can see the preservation is very, very nice. You can see the cells, and this one is a complete one, so you have the whole circle intact. And on Livingston Island, there has been described 3 different species from different stratigraphic levels, and newer work has decided that 2 of them belong to Millerocaulis, and the third one belong to some other genera. And these are all from Aptian, or they are Aptian in age. So just to give you a more technical drawing of how it looks when you have these stems that develop into leaves, and you also have roots coming out in the from the rhizome. This is from a newer study by Baumfleur et al. In 2017. Here is an example of what I could see when I had synsection made of the fossil that we found on or in Santa Marta Cove. And again, you can see that it's half compared to when I showed you the complete one, but the cells are still very well preserved, and there are lots of details that I won't bore you with because you are not maybe into the plant anatomy as some of my colleagues, but what I want to show you is, or at least point out, is that this one is a leaf trace, and the little round one out there in that figure is a root trace. What I did was that I took one of the leaf traces and compared it to the material from Livingston Island, and then I compared it to an extant, meaning a plant that lives today that I happen to have in the teaching collection at the University of Alberta where I'm teaching, and you can see the similarity from the find from James Ross Island to the older Livingston material and then to the extant. And that, as I pointed out earlier, is a very interesting thing that you can go so far back in time and still have these cells preserved so well. And just another example of how these leaf traces look in the material. There is unfortunately a lot of minerals. The very black stuff is minerals, and they doesn't let the light penetrate. The middle of the stem is where the xylem is, and that's what is very characteristic, and within the plant anatomy it has of course a very complicated name. And I tried in the old-fashioned way to compare my material to what had been found in the general area of that part of Antarctica. And as I mentioned, there was at least 3 species known from Livingston Island, and then I compared it from looking at the morphology and the anatomy of what I could see in the rhizome. However, nowadays it's not enough just to do morphology. You have to come up with something more interesting, and in the time between these publications came out that I was using, this paper by Baumfleur came out, and they are using a new way to look at not just the fossils, but they compare it to the recent material. And because these rhizomes are so characteristic, and this goes all the way back in time, you can see this time over to the left, and what they are trying to show is that, of course, the characters go through to extant members of the group today. But they do a planar network, which is depicted here, and I have to get my thoughts wrapped around these new ideas to be able to actually place the fossil that we found into this. And what they are using is they are using 45 different characters that they score on these different fossils. So they have actually picked up everything they could find that was fossil and what was extant members of the family, and they are now building this new way of looking at it. And just to show you that Millerocaulis is this spider web, and what they are trying to show there is how different genera are placed, and that these species within the genera are cluttering together in different patterns. And I am just trying to work on this new method to identify where my or our fossil fit into to the picture. What I want to emphasize is that in past, the fossils are known from all over the world, really. I mean, Antarctica, as I have already told you, from Argentina in South America, and it's known from the Jurassic of the US, and in Lower Cretaceous rock from Western Canada. It's known from the Jurassic of Sweden, and it's known both from India and from China, Jurassic rocks, and it's also known from Australia. So a huge geographic area, whereas today it has a much more limited area, and that is why I think it has been so attractive to use it. However, we place our Millerocaulis very close to where Antarctopelta and Trinosaurus was found on Santa Marta Cove. And with that, I'll just show you one more picture of the living Osmunda and our reconstruction. And then I will say that without Phil and Rodolfo being my companion in Antarctica, I don't think I would have done so well, because it is a very rugged place to camp and survive. I have never in my life experienced such harsh weather. The wind was just absolutely ferocious. We didn't need a dinosaur there. It was so windy that yeah, I just haven't experienced anything like that. I have experienced wind in Canada and Greenland and in Denmark. Phil always says that Denmark has the windiest weather, but down there, there's nothing to stop it, and it was amazing to experience. But on the other hand, I'll say to the young women in the audience, don't feel intimidated by it, because it's all possible, and it's just a matter of, getting into it. And with that, I'll acknowledge the different institutions that helped us with funding, and the people who helped with doing the SIN sections and some of the work at the university. And with that, I'll say thank you.